I wear two hats. I have two full-time jobs. I am the CEO of ProHabits. ProHabits is a digital marketing company that's focused on employee campaigns. And I also am a managing director of Hubvince, which is a BI think tank, and we focus on how to solve business problems and drive business outcomes using Microsoft technology stack. So today I'm going to go over our use case, talk about how we implemented Fabric to fit our needs, some of the challenges in retrospect from our implementation as well. And then we'll leave some time for your questions. So let me frame up kind of what's happening in our scenario. So we're a digital marketing company, which means that we focus on is sending the right message to the right person at the right time. And the way you do that is by having lots of data, right? So, and because we're an employee space, our data is employee data, which means that that's the kind of data that no company will ever share with anybody, because it's literally the most sensitive data asset that they have. So that was the issue we had to figure out. The next thing is, let's say there is some data that companies will share with us. It doesn't mean that they're not going to make us work hard to get this data, because they care about where do you store it, how do you store it, what do you do to make sure that this data does not grow legs, and they don't make it easy for us to get it. The next piece is that data is not just sitting waiting for us. Data sits in SAP, data sits in Workday, and customers make us work hard to get to that data, put it in a format that we can do analysis on it, and then put that data to work. So the question was, what does success look for us, and how do we solve and address these issues? The way we solved this was by implementing a hub and spoke architecture for data management. So our mothership is the system that sits in a central repository for ProHabits repository, where we get non-sensitive data. We then run our employee campaigns that generates impressions, clicks, conversions, and engagements. We then find a way to deposit that data back into the customer hub, and we do this in a secure and performant manner. We also had to figure out how to dramatically shorten the security review process. So we do a lot of this at bets. We talk to companies, they all have very rigid security requirements, and we need to put folks to ease that when they share the data with us, it's going to be in the most secure place possible. And Microsoft Fabric has all the certifications, and that really, just to provide the answer right away, that really allowed us to gain that objective. And lastly, we had some issues with data enrichment. We had very difficult challenges that we had struggled very much with traditional data engineering and ETL use cases. I will get into details a little bit later. That's where generative AI, LLMs will come in. So we're able now to tackle, for data enrichment, where we had to write store procedures and very crazy data integration tasks, we're now leveraging the power of LLMs and Gen AI to dramatically speed up that process. So our solution was twofold. When the Fabric went into preview, we jumped right in. So we did a crazy thing that I do not recommend, right? If you want to build a production-ready customer-facing software, definitely by no means do I recommend putting something in production that's not currently GA, but we had some reasons. And also, just to be transparent, I had worked with Microsoft for about a year before it went live, so it was not new to us. We were very well equipped to put it to work. So our first phase was so we basically lit up everything. So our data integration used Dataflow Gen 2, and we had those puppies running every hour, which we learned later had some considerations, and you have to be really thinking about a couple of things when you work with Dataflow's Gen 2. We use Dataflow's data pipelines for orchestration, and one of the big decisions in data integration is where are you going to be writing your data into? And our solution was to pick data warehouse as the main data repository. So most of our jobs were actually writing everything into data warehouse. So to the Creative Fabric, the amazing thing happened, and we had a major gap. Our solution initially was based on Amazon backend, and we're using Google Analytics Suite. And whatever issues we had, we're able to rapidly develop and fill those gaps using Fabric. However, at the same time, we experienced a number of growing pains. Now, you got to put it in context. because we were using a non-GA software, right? So things were rapidly developing. Every week or every 2 weeks, there were new fixes. You had to do things this way, then we had to do things another way. So not to blame by Microsoft, but it would be unfair for me to say that everything went smoothly. We did have a lot of challenges, and most of those challenges have been dramatically reduced or on the path to reduce it, but happy to tackle them as we have our Q&A session. So our challenges were data flow performance, so a lot of performance stability issues, and we had them both on data integration side and data warehouse side related to data integration. So we had issues where we would write that data in, then we query data warehouse, data is not there. We're like, what the hell is going on? We write a query in the web interface, data is there. We write the same query in SMS, data is not there. So there were some kind of growing pains early in the process that now have been taken care of. But absolutely, we had to learn a lot before we got it to work. And what we learned the hardest, and that's very important for data integration conversation, is that throttling is a big deal. I don't know if you guys have ever seen your capacity in throttle state. I do not recommend it. It's not for the faint of heart. And what we understood is that for several months, everything just ran, right? You kind of take everything for granted. And then you start thinking about, oh my God, I have now 3 things to worry about. I have a cost component to my architecture, I have time to market component to my architecture, and I have the performance component to my architecture. And you can't get all 3, right? You have to pick what you want to optimize. So when you rapidly develop a feature, you might say, look, I'm going to pick, for example, Dataflow Gen 2. That's going to give me that integration and transformation capabilities rapidly at a cost of maybe having to run it into bigger capacity, right? So we had to really figure out and look at all of the components of the architecture and try to get a gauge on, in terms of cost and performance, what are my levers? What can I dial up or down to get, for example, the window by which all of my data has to be ready for analysis, data quality issues, dealing with all of the other things, given the cost constraint, because I can't afford to run, $1 million of fabric capacity quite yet in our phase, right? So we have to balance all of this stuff out. So when you think about data integration, you can't just think about the functional side of it. You have to think about time to market, and you have to think about the costs. So then in phase 2, we said, okay, now that we've learned and we got a lot of bruises, how do we reshuffle our architecture? And what we did was, in phase 2, we said, instead of playing the catch-up game, and it's amazing how Fabric and continuous Microsoft Power BI tradition to rapidly innovate and rapidly deploy features, right? So we all love this, but when you're trying to get a stable production environment, particularly in a life cycle of Fabric that it is right now, we had to figure out, okay, how can we put something in place that's going to give us 6 to 9 months of the runway where we don't have to constantly play catch up, okay? So what we did, we said, let's take our environment and break it into 2 areas. We're going to have a production stable environment, and we're going to freeze new features in that environment for 6 to 9 months. And then we're going to have a playground, sandbox environment where everything is still running and we're still doing all the things that we like. So in phase 2 environment, we made some dramatic changes. So now the biggest change that we've learned, and happy to have this conversation, is we moved away from data warehouse into a lakehouse. And there is serious data integration considerations to consider, to think about when you're trying to figure out where you're going to drop your data, right? So for us, and I'm not saying that it works for everybody, lakehouse is where it's at, big fans, and that actually is giving us the 6 to 9 window foundationally. The next thing was we moved a lot of transformation into Spark notebooks. And happy to talk about this. What we did there, so let me kind of show you hopefully this is big enough. So, yeah, so basically what we did, so we're still using Data Factory. Let me talk about notebooks a little bit in a second. But so Data Factory is used quite a bit still for data orchestration. And there's a couple use cases where it's really invaluable, right? So Data Factory with fast copy, I believe it's in public preview. We're having amazing results. So we're moving, even in a small capacity, we're able to move billions of rows of data in a very performant way. So I believe it's in public preview, right? Okay, so yeah, so definitely recommend if you guys are trying to figure out to move large volumes of data sets in parallel, fast copy is something you should be looking at. And then we're also implementing mirroring. And mirroring is a game changer. It's a beginning of being a game changer for us because we have a heterogeneous data source situation. So currently it only supports a very short list of data sources to do a real-time replication from your sources into your Fabric environment. The data actually goes into a warehouse environment. So I think once more and more data sources are supported in mirroring, that's going to remove a lot of, it's going to make us, again, reassess how we architect everything, right? Because today we spend a lot of time acquiring data, keeping everything in sync. With mirroring, you basically get that data in sync, in real time, and virtually basically for free, right? So there's a big cost component. As I said, everything you do in Fabric, if you don't have a handle on cost, performance, time to market, then you're doing yourself a disservice. Literally every decision has to be done through those three lenses, and mirroring the cost and performance really get really high marks. So let's talk a little bit about look at my watch, make sure I don't spend too much time on this, notebooks, right? So notebooks was our skill set, so you guys might be in a different situation. If your skill set is T-SQL heavy, you might say, okay, data warehouse makes more sense for us on the transformation part of the data integration. We're ambidextrous. We're happy to do T-SQL, we're happy to do Python, we're happy to do PySpark. So all of those technologies are easy to us. So that was not a consideration for us. So for us was more of a capability play. So what we did was we implemented a rich metadata-driven approach where all of our sources, we track them in a table. So every table in our list, think about this way, in our metadata, we know the table location, the JDBC driver we need to use to connect to the data, what is the key field, what is the timestamp field, and once we collect all this data, metadata for all of our sources, we're able to then to write a notebook that parallelizes a bunch of these operations, and then it basically runs code to virtualize access to all of those data sources. So now we have virtual access to all of those tables, and it's easy for us to implement incremental and also full-time loads. And the other piece that it allows us to do is to get into this Gen AI game that I'm going to spend the last 10 minutes and hopefully get you guys all super excited about it. So let's talk about the generative AI and where it fits into data integration and data engineering use case. So I will give you an example. So what happens in our world, we collect data, we collect stories from our end users. So it's a kind of poor man content moderation use case, right? So stories come in, and some of those stories have, let's say, less than Shakespearean verbiage in them, right? And we collect them at industrial scales. Thousands and hundreds of thousands of messages come in, and then those messages potentially go on a CEO dashboard somewhere, and physically nobody's able in real time to moderate, read all those messages, and figure out what's happening. So initially what we said, we're going to say, okay, well, there is only a handful of bad words in English, let's create a dictionary and do some sort of string manipulations, find and replace all the bad words with asterisks or something a little bit more plausible. Well, then we realized we have people who speak Spanish. Then we realized we have people who speak Ukrainian and Polish and Chinese and French and every other language possible, and I can't even swear in all those languages. So I couldn't possibly even build that dictionary. So what do? Well, so I was scratching my head. I really could not understand what we could possibly do with the traditional data integration, data engineering tool set. So I took one of the super spicy stories, I went to ChatGPT, and I just said, listen, can you take this story and just remove all the swear words with asterisks? And bam, the response was right there. So I'm like, if I could just do this in Fabric, that would be amazing, but how could I do this? So I talked to my friends at Microsoft, we had to pull some bright minds together, and I was able to then run a ChatGPT-like completion, right? So we instantiated Azure OpenAI, we connected our notebooks to Azure OpenAI, and now we basically just write prompts and say, hey, run through all of our stories, take a data frame, take a table with all of our stories, and add another column, and replace all of the bad words with asterisks. And literally it runs, and then I take hundreds of thousands of stories, and I convert them into a PG-13 version of those stories. Then we said, okay, how do we take that meaning of this really spicy story and condense it down to word cloud. So we're using some technology in Amazon to help us build that word cloud, but what it did, it used existing words from the message to come up with a word cloud, and believe me, those words you don't want to see on your word cloud, right? So we said, okay, how do we use Gen AI to help us? Gen AI took that spicy story and converted it to the word incompetent, which is really what this person was complaining about his manager, right? Then we said, okay, wow, well, we have a lot of data that comes in lat longs. How do we convert it to a zip code? Well, I'd have to figure out some sort of geospatial capabilities in my database. I have to buy the service. Well, or you could, again, write a prompt and say, take this lat long and convert it into a zip code. And bam, it's that easy. Then we said, okay, what else does it know about zip codes? Well, we're in digital marketing space. Can we get demographic information? Can we get affluence, education? This thing is trained on, what, 1.4 trillion attributes? It literally knows a ton. And we started using our data now with all this demographic information. And the next step was, okay, well, the problem with ChatGPT and all those models, they're trained as of April 2023. I want to get the response that's relevant to my data. And obviously, OpenAI and those models, they have no understanding of my context. So there is a way that's solved. It's called Retrieval Augmented Generation, RAG architecture. And that allows us to basically bump together my data in PDFs, my data in my other assets, and put OpenAI LLM models to then answer questions based on my data set securely. And we got that to work. And then the real question is, well, what is next, right? So what is next is, here's a scenario. Imagine about your organization, and you have a set of KPIs. And so that set of KPIs kind of tells you the health of what's happening right now. Or, let me give you an even better scenario that everybody can relate to. You have a car, the car generated some codes. There's check engine light, there's some kind of error message, and you're saying, okay, what do I do about this? So you pull that data in, and now in your batch job, you want to actually figure out what to do about it. Well, you use your Power BI, you move the data from your sensor into your environment, you use fast copy, whatever you might do. So now that data is available. The next step is, what does this mean? I need to really understand. So normally it would be, pages and pages of if-else logic to figure out some sort of decision tree to figure out how to deal with the scenario. Or I have a user manual. I could just take that error code or combination of error codes and literally write a prompt and say, when you see this, what does this mean? And it's going to go to my PDF document and say, oh, you have oil situation, or your transmission fluid is low, or your wheels are about to fall off, right? So I have to have a document that keeps track of what's happening in my organization. I just do a prompt. Basically, I use language to figure out what the situation is. The next thing is, what do I do about this? Well, I have an SOP document that documents what needs to happen when something occurs, right? So is this a text to somebody? Is it an email to somebody? Do we need to leave the premises? So now what I do is I do another lookup in another PDF document, and that's all happening in my notebook. That's all happening in an ETL job, right? So during my data integration. So now what I've done is I've taken what potentially would have been thousands of lines of stored procedure, or some kind of logic, or some kind of rules engine, or decision tree, right? I have to pull all of this together, and I literally replaced it with 3 prompts. Tell me what's going on, explain to me what that means, notify whoever needs to be notified that this is happening. So I think this is an amazing capabilities, and I think the only real question is, hopefully you guys are all super excited that now this capability is available to us, right? So there's probably 2 camps. Camp 1 is thinking, I don't really care about this. I can't even get Fabric turned on by our administrators. And that's similar to how dinosaurs probably thought at the tail's end of their evolutionary curve, right? And some of us are thinking, okay, I gotta put this to work. This is amazing, right? So then the question is, well, is Fabric the right platform? That's really the question, right? And what's amazing is we're able to do everything I'm talking to you guys about right now today in Fabric. So that's available. So that makes me feel that we in my company and my organization, we made the right choice. So that's it for me. Sorry I missed this slide, but that's about it. And then I think once Tom is done for his session, we'll be open for questions and answers. And what do you do?
Thanks, Andre. Yeah, English too. Right, hi everyone. I'm Tom Peplow. I work for a company called Milliman, and we build a product called Integrate. I'm going to need to give you a lot of context because I work in actuarial science, and I doubt many of you are actuaries in the room. Hands up if any of you are an actuary. I'm not an actuary. So, okay, we have no actuaries, so no one can call me out that I get this horribly wrong when I try and explain what an actuary does. But we have a platform that we built on Azure that's been in Azure since Azure was called Red Dog. I joined Milliman to help them build the first iteration of their cloud platform, and it runs actuarial models at scale in Azure. This story is about how we're migrating all of that work over the last 12 years, at least while I've been here, to use Fabric, with the goal to make it faster, better, cheaper for our customers and reduce our total cost of ownership so that we can free up our engineering talent to do all the cool Gen AI stuff Andre spoke about. Actuarial science is a really hard domain, and it's going to really benefit from generative AI, so it's important that we push our product forward so we can serve our customers. Right, so Milliman, I doubt any of you have heard of us. We're a consulting business that's kind of diversified a little bit into services and products. We are all over the world. We advise customers in every country that you have insurance in, and we work in property and casualty, car insurance, health insurance, life insurance, which is where I work, and employee benefits. And we have deep subject matter expertise. We have some of the best and brightest mathematicians in the world working for Milliman, solving some really hard problems for insurance companies. Recently, a lot of our growth has come from products. So we've taken all of that knowledge that we've gained working with our consultants and put it in a box and given it to our customers to leverage. And like I said, I'm responsible for the strategy of one of our largest products called Integrate. We're about $1.5 billion in revenue, and we're about 4,000 people. Our mission is to help our clients protect the health and financial well-being of people everywhere. Insurance it might be dry, but it's kind of important. To have a functioning economy, you need a functioning insurance industry. And the world is getting more and more risky. The world's getting more and more connected. There's more and more things going wrong. And there's things like climate change that are having some pretty severe impacts on everyone, especially insurance. And if you're in California or Florida, you'll know about this. So I'm specifically interested in our business about retirement outcomes. So we look at life insurance, we worry about what happens when you die, or can you have enough money when you're retired? And to solve that problem, we need to do some pretty complex data engineering, data science. Actuaries are probably one of the first data scientists around. Actuarial science was invented in the UK so that people who wanted to ship their goods around the world on boats could get an insurance policy for the goods they put on the boat. So they needed to understand how much the goods were worth, where it was going, what the seas were like, and they gave you some price to cover if your box fell off the boat. So now we just do that, for a lot more things. Insurance is embedded in everything we do on a daily basis. Okay, so Integrate, like I said, is for life insurance actuaries. There's a lot of analogies here to what you probably all do as data engineers, data scientists, database administrators, all that kind of stuff. It is just a big data process. In the heart of it is a very complicated actuarial model. I'll get to that in a minute, and I'll try and explain the inputs and outputs from it and give you enough context so you can understand why we do what we do and we're not completely mad. But if you think about what an insurance company has, it has policyholders that need coverage. They pay premiums as they live, they pay money. And at some point, they need the money back. They either get it as an annuity, as a cash flow when they retire, or they get it as a lump sum if something bad happens. These policies last a long time. That's what makes life insurance different. A life insurance policies are long duration contracts. You have them. You might pay into a pension all of your life, right? So these things take a long time. And what makes it really interesting is the assets that you buy don't have the same duration. So if you think about it, when you invest money in bonds, they expire, and you have to buy more bonds. So we also need to understand, we take those cash flows of liabilities we get from policyholders and we put them in assets, and those assets also give us a revenue stream. And then what we need to do is take those two pieces of information and figure out what happens when things change. So one other input that doesn't, that actuaries have to think of is what are all the assumptions we make. So how often do people lapse policies? You don't know, you might have had insurance and decide you didn't need it anymore. You might buy a bigger policy. You might change your terms. All those types of things need to be considered because that cash flow into the future, 40 years into the future, is going to depend on those assumptions. You have mortality that happens. So you need to understand what your exposure is to mortality risk and then morbidity risk and all these types of things, right? So they have tables of data that they use data science to figure out the values of. So if you're a 40-year-old non-smoker that drinks a lot, what's the likelihood you're alive when you're 55, right? And all of those types of tables are all inputs to these models, and they need to do data science to figure out what the values are for each of those things. And then on the economic side of things, there's rules that govern how these big systems that we live in work, right? And economists think hard about what those rules are. And what we can't do is look in the past. We can't look at asset returns from the past to predict asset returns into the future. There's famous quotes, past performance is no guarantee of future performance. So what we do instead is we generate random scenarios for the future. And then we run these models with these assumptions through those scenarios. And the more we do, the better picture we get of all the possible futures that could happen. You have these things called black swans because these economists are wrong, and they know they're wrong, right? These models are definitely wrong. The answers that they put out are almost certainly wrong. So these economic scenarios do change over time, and they need to be configured as well. So we have a whole load of input. Some of that input is really hard to get to because insurance companies are old. We have a similar problem to what Andre explained, but these are all mainframe systems. If you think about it, we've got insurance policies issued 40 years ago. In some systems, some have been built 40 years ago, or at least turned to digital some point between 40 years and now. So we have all these really legacy mainframe systems all over the insurance company. Insurance companies buy each other all the time, they reinsure each other, so this data estate is just possibly the biggest mess you'll ever likely to see in your life. So we need a way to wrangle all that input into what we consider a canonical format for our models, right? So our actuaries build a model, they say these are the fields we need, they have to go get it from all of these sources out there in the world. And on the output side of things, we have huge amounts of data. These models produce petabytes of information every time they run, and we need to condense it down so somebody can look at them. In the future, a machine might look at them and give us some insights, but right now people can only look at so much information at once. So on the back side of all of this, we need a big data reduction process. Now, like I said, actuarial science is really hard. My background's software engineering. I basically told you everything I know about actuarial science just then. So what we try and do is democratize building of this system so actuaries can do it for themselves. And that's where Fabric's very interesting for us, because 12 years ago, there wasn't Fabric. There were all the building blocks. If you remember the slides from yesterday about Chief Integration Officer, that was my job. I was plugging together all these boxes of all of these systems and trying to make it work. So now Fabric exists, we have to think, how do we take all of these things that we plug together? Because our goals are the same. We want to give actuaries the best tools they can possibly have to manage the risks in the world the best way they possibly can. We have differentiated intellectual property that sits in the middle of this system, and we want to integrate that in with Microsoft's products in such a way that actuaries can do it for themselves. There are some problems they need their software engineers help with, some really difficult stuff that requires programmers to do, but 9 times out of 10 they can use our platform to do it all themselves. So before Fabric, this is what we did. We embedded Microsoft mapping data flows into our product, so actuaries could build the data processes for themselves. And they've spent millions and millions of dollars with our consultants themselves building these processes, and they're in production today and run. So we can't ask them, please rebuild them in notebooks. That's not going to go down well. These models are complicated, they're regulated, they have to be signed off and tested. There's no way on earth that we could shift all of our customers to a brand new platform without keeping the old one going at the same time. And on the back end, we have Power BI, so that they can look at the information they have. This is gap disclosures. Gaps as an accounting regime in the US. Now, again, this is an interesting analogy to Fabric because you can see some of these capabilities coming in now, but I don't know if any of you have used Power BI embedded, but it has great APIs for you to interact with the reports, and you can put your own things around it. So one of the things we put around Power BI was the ability to sign off results and these discussions around it, because again, these models are wrong, are they really wrong, or do we need to rerun them? So this is something that we allow people to do in the platform. This also needs to continue to work. You know, millions of dollars of investment in Power BI reports, and all of the intellectual property we've put around it and all the features, they all still need to work too. Right, so this is what our current architecture looks like. You know, we're a SaaS platform. Insurance companies all around the world can use it. When they run these models, they might use 200,000 CPUs. One customer might use 200,000 CPUs to run these big models, to do all this random number generation and modeling that they do. Produces petabytes of results from these models. And right now we have 6,000 storage accounts. We didn't have a one lake, we have 6,000 one lakes. So math, you know, I don't know what it said yesterday, but yeah, it's not one lake. And we have all these data processes, really, really complicated actuarial business logic embedded in them that we need to love and move forward. So the challenge is, though, is we always need to make things faster, better, and cheaper. So how can we do that? What can we do to improve the performance of our system? It takes a long time to process petabytes of information. And new great features like the fast copy that we spoke about earlier is huge for us, right? We want to give that to our customers. We need better connectivity with our customer systems, right? Even though they're obviously complicated. A lot of the time running these processes is copying information from our client to us and back. And I forgot to mention this, but the regulators say to an insurance company, it depends on the regime, but every quarter or every month, can you run these models and tell us how you are? Are you still solvent in a year's time or not? So the time it takes to run these models is really important, because the regulator also says is you've only got N number of days to run these models, because they want to know that it's a robust process that does it, that it needs to be a properly engineered thing, that also people aren't going into and fudging the numbers, right? It's not good to go run these models and find out you're not solvent in a couple of years' time and have someone go and change the numbers so you are. So it needs to be rigorously built and easy to run, and the results need to be managed. Now the results, like I said, are wrong, and they do things along the way to kind of adjust for things that you didn't expect to happen, because these systems are very complex and building models to model them is very hard. So again, that feedback loop, the quicker you can go around it, the more time you have to get those results as close to right as you can and react in real time. And now, because the world's getting more and more risky, insurance companies want to run these models daily. The goal is to be able to take current Bloomberg market data, run it through these models, and get an answer on your solvency on a daily basis. We have a customer doing that right now in the UK. They use a very sophisticated data science process that's a proxy of our actuarial model to do that. But we want to do that more for people, and that's kind of where the generative AI capabilities can start to come in to speed up that feedback loop even quicker. We want to reduce our total cost of ownership, so all of our engineers that are currently building this can start doing the thing I just said, right? Getting it so that we can run this on a daily basis using generative AI to answer really tough questions. And we also want to do it in such a way that all of our customers don't notice we did anything. There might be, I said no brackets minimal because my team told me there might be some changes our customers need to do, but we want there to be minimal upgrade cliff. So this is what we have done. This isn't in production with our customers today. This is something we're experimenting with internally. Like I said, these systems are important. They need to not break. So we're doing a lot of work to make sure this really does work at scale. And the scale we're going to push Fabric at is probably beyond what Microsoft wants us to push it at. We're going to stretch its legs here with what we're doing. And it's an incremental process, so we've got lots of increments going to get us completely migrated to Fabric. But this is increment number one. So we're going to get our high-performance computing platform to write directly to OneLake through its Data Lake Gen 2 APIs. So we can do that, I'll show you in a second. Then run some Fabric pipelines to move that data and stick it in tables. Then change our mapping data flows to run on top of those tables. And then get rid of SQL, because who wants to copy the data into SQL? Mirroring's cool, but I don't want to go into SQL. I don't mind mirroring data from SQL into a warehouse, but I don't really want to go into SQL. The only reason we have SQL is because Power BI needs somewhere to go get the data from that's not blob storage or something like that, which is where people love our data. But now we have the capability with Direct Lake and Lakehouses. Let's try. We'll get to the feedback in a minute, but there is a reason we're using the SQL endpoint instead of using Direct Lake. So the payoffs are, we hope this is going to be a lot faster. I kind of know it is, but I don't want to, if there were a customer in the room, I didn't want to get them too excited about how much faster it's going to be, but we hope it's going to be a lot faster. We know it's going to be a lot cheaper. There's a lot less moving parts, and our total cost of ownership is going to be a lot less. And this is just the first step. So like I said, this is what we've done. Files written to the Lakehouse. This is just test data, it's just small stuff, because what's the problem with this is it costs a lot of money to test this process works. So every one of those jobs running on our high-performance computing platforms writing its merged output, there's another problem that we have to solve, which is how do we do merging and using Fabric. We'll get to that one day. But right now, the final result of each of those jobs is written, and each of those jobs is one of those folders. Then we wrote a notebook to turn the CSV output from our calculation engine into tables. You know, we will go back and refactor our calculation engine to write Parquet itself, so we don't have to have this step. But again, this is a nice incremental way for us to get into the new world. And then we orchestrate that with a data pipeline, with data pipelines, right? So we run the notebook and move that into tables. We'll come back to some lessons learned, whilst I'm thinking of it now. One of the things that really helped us was taking more of a micro-batching approach. So rather than doing it when a file arrives, what we do is this runs on a schedule, and then all of the files that arrived in that period of time are then moved at once. That meant that we didn't have loads and loads of notebooks running concurrently, which meant that we didn't get into capacity jail, which is a pain in the ass, which you said. So we did some things, we learned some things along the way quite quickly there to have this. This is an area that we would like to see improved with Fabric, is that this triggering and this debouncing that we're doing ourselves is being done by the platform. But this is pretty cool, and this is pretty fast to run. Like we're showing in here, we do have a copy activity. Right now, I think the notebook can write directly to OneLake and not need the copy, but the team had some challenges getting that working, so we'll come back to it. So there might be ways to optimize this process as well to further improve the performance of it. And the last step is all those, and there's probably lots of questions in the audience, or at least I've heard lots of questions in my time working with the Fabric team. You know, and similarly worked with Fabric whilst it was in preview. Is how does it going to work with all the stuff that you've already got in production? Azure Data Factory supports reading from OneLake and writing to OneLake, which is great for us because we can modernize all of the underpinnings of our platform, make it a lot faster, better, cheaper, and all that existing stuff. And mapping data flows is great. It runs really fast. It scales really well on Spark. There's no reason to move it anywhere right now. So let's just make it work on top of Fabric, and that's what this is doing here. So these sources and sinks now are reading from tables inside of OneLake. And what's really cool about this is one of the questions I get from the actuaries all the time is this big process that's got thousands of steps in it. How's it going? Is it working? Now, right now, it's a data engineering job to move status and put operational data out into a reporting database for someone to look at in Power BI. And some of our customers do that, and it's really cool to see. They have these like really good operational dashboards around the process, and they can look at numbers as they're being generated. But it takes a lot of engineering to build that in, right? And sometimes you just want to go look at the data. And that's what's great with this, is now all the data's in OneLake, and now we have the ability to share our data in our OneLake with our customers. Now they can look at this thing running. So sharing's got two payoffs for us. One is you can look, like here I'm doing a look at all the policies going through these jobs. They're all the same policyholders, we're just running different scenarios against them. But you can look. So you couldn't do this before. This is a net new capability, and that just comes from us sharing our data with our customers. But this is the real payoff. This is where we want to get to. This is the desired end state for Integrate, is there is just one data set between us and our customers. We don't want to have to copy petabytes, gigabytes, terabytes, or whatever bytes is from where we are to our customers and back, right? That's the biggest cause of latency and the biggest bits of errors in this process is just that disconnect between us and our customers. That's a really hard problem to solve in a really elegant way, and that's what Fabric does do with the OneLake and the external shares. What did you call it? Data sharing? OneLake shares? Yeah, OneLake data shares. So now with this, so our customers and us, as all the data is just together, you can't really tell that it's Integrate data or customer data. And then with one security coming, all of the permissions on how and what we share and when, and everything's just in real time. So that's where we want to get to. And then the capabilities of Integrate that we've built continue to work, and we'll continue to invest in that, so our customers don't have to be Fabric customers for us to be able to do an implementation of an actuarial modeling system for them. But if they do happen to be a Fabric customer, they can have all of the data that we're generating and then look at it themselves and build processes around it themselves. So this is a huge step forward from where we are today with our information in a silo. And that's really what we need to do to unlock the potential of these actuarial models. We need to connect up our data better with all of our customers' data so that we can ask really tough questions. like what's the solvency of our business today given interest rate rise, right? That's what the CFO wants to ask. And he has to ask an actuary, the actuary has to run a model, that model has to produce some results, they have to wait hours for it to run, and then they get the answer. What we want is the CFO to be able to ask that question in natural language. You know, what's the effect of interest rate changes today on our business, and get an answer for it. Now that requires lots of systems to play together, right? Bloomberg is a source of information that we need to know. That data needs to be up to date. There's lots of other pieces of information that need to come together for that to be well understood. The accounting systems need to be updated with the numbers from us and all this stuff. So it's a very easy question to ask, but a very hard question to answer. And we want to make it easy, and we can't do it alone. We need to be open, so Fabric will open us up. But what happens if Fabric doesn't work? So I'm optimistic, but I also work for a company that manages risk. So what happens if it doesn't work? So I always hope for the best and plan for the worst. Now, what is good with Fabric is that it's built on open standards. All the data in one lake is just Parquet. There's loads of systems that can read it. So for me, what's the most mature piece of Fabric? It's probably One Lake, right? And I don't want to play disservice to One Lake, but it is a veneer over ADLS Gen 2. We're already using it. It's already super scalable. We already pump petabytes of data into it on a daily basis. So I'm not worried about that. But what I do like about that is that it's open and all these systems connect to it. You saw yesterday Databricks' Unity catalog is on top of it. So let's say we couldn't use Fabric Spark, for some reason it didn't work. We can use Databricks' Spark engine. If our customers are Databricks customers and they already want our data in Unity catalog and don't want to move to One Lake for it, if they're an Azure customer with Azure Databricks, they can have that information in the platform. So for me, it's a natural, easy, incremental step. We can stop at any time, we can do something else, and we're just making it better step by step. This is the team that did all the work that I just showed you, other than that one in the Seattle-looking shirt. I'm English, but I live in Seattle, but this is the team that built all that, so you don't need many people to take advantage of Fabric. It's not hard, and you can move really quickly. So we're feeling pretty confident about where we're getting to and the pace at which we can get there, but we're not locked in, and that's important. You as a Fabric customer are not locked into Fabric. You've got all these systems that can connect to, it helps you connect with your customers, but it also helps you if something doesn't work, you've got options. And this is the early feedback the team gave me is, like I said, we did the micro-batching thing that was kind of something we discovered ourselves on the way and could solve for, but we really, really want some better way to trigger things happening, right? We want reflexes are great, but they don't trigger pipelines. We need a reactive. I'm a big fan of event-driven architectures and reactive programming models. The world is asynchronous. We need to be able to process events in real time. So please help us do that inside of Fabric. If a file arrives, let's run something. Let's get on with it. We have our own orchestration system. That's one of the things that we still maintain, and it is a big directed acyclic graph of all these transformations that happen. And it manages it between our compute platform and our data platform, and we string all this together. It would be great if Data Factory could just do that. It doesn't today, doesn't work at that level of scale that we need it to work at. We would love it if the orchestration engine lived inside of Fabric for us, all up, and orchestrates our compute platform and our models. That would be amazing. And this is why we use the SQL endpoint, because right now you can't take a Power BI report that's looking at a direct query Power BI report and connect it to Direct Lake. You need to do a bunch of stuff. Now we can programmatically manipulate the models, I would imagine, to do it. And we could build that. I'd rather not, I'd rather it just work. And right now there's enough of a payoff to speed up that data pipeline to receive like the upside of the reports we think are just going to be just the same performance, if not a bit better, maybe a lot cheaper on Fabric with the SQL endpoint, but I really want to get to a point where we're using Direct Lake. So that's it. So I think I've left us 15 or so minutes for questions. Hopefully that generated a lot, so please ask. Yeah.
I was just curious about your process. Like, are there inputs that don't require you to go through that whole pipeline of rebuilding those predictions, or does every change, no matter what it is, require kind of complete refresh of that model?
Yeah. The answer is yes and no. It depends on what changes, and knowing, and that's part of that graph. If you think about this DAG.
Can you restate the question?
Oh yeah, I can restate the question. So, what was the question? I'm joking. So we have all these inputs. What happens if one of them changes? Do we have to rerun the whole process or not? Is that right?
Yes.
Yeah, cool. So it depends. Yeah, if the changes to the model, yes, we have to rerun everything. The model can change in cycle. That's something that could happen. If it was the mortality assumptions that changed, we only need to rerun the mortality stresses, right? Because the way the math works out with the actuary, it's very, very hard to create a model that does everything all at once. So they run some runs for mortality, some runs for mobility, some runs for all these different things. So the system can do that and rerun the subsets of things. And it does that because we have this graph and everything. It is a very simple graph, like mathematically, it's just a directed acyclic graph. So you can calculate what edges need to be reevaluated when a node changes in the graph. That's what I want the data factory system to do though. Because if you think that, it starts to get weird when nodes in the graph require incremental refreshes, right? So we have we built our own Delta Lake format many, many years before Delta Lake existed, and it supports us changing subsets of the data that underpin the database, so we can bulk load just subsets in. If you think on the back end of this, you've got something like Delta Lake tables that supports time traveling queries and all this kind of stuff. You can just make incremental changes to that, and then things refresh, and then you still have your reproducibility. You can go back and look at what it was before and what it was after, and those types of things are all considerations we have to make when we rerun these models. But yes, we can kind of do it.
It seems like the better you're at, you get it that helps with cost as well, right?
Yeah, for sure. No, if you the better you understand the subsets that you run, the a lot cheaper it will be in the future, for sure. Yeah. Yep. What was Microsoft's feedback about triggering? What is Microsoft's feedback about triggering, Sunil?
Repeated fabric information. Stay tuned.
Yeah, I can't make commitments on when it's going to come. I think they heard the request though. Am I asking for feature parity with normal ADF? I did ask for that. One of the interesting observations you'll make is mapping data flows isn't in Fabric. That was a heated conversation. But what we have is interoperability and the commitment that it's not going anywhere. Yeah. Did you put your hand up?
How do you share data with your customers?
How do we share data with our customers? Right. So yesterday they announced this, so it was been in like private preview for some time, but the same way the same way you share data between lakehouses internally is the same way you share it with customers, just with a little bit of an extra step to give them some information. Yep.
So to clarify, shortcuts between lakehouses even internally, that's all virtualization. There's no
Yes.
copy of the data between each instance.
There's no copies made when you use shortcuts, correct. And that will be the same when you do external sharing with other people. Yep.
What do you guys use for graph data?
Oh, we built our own thing. Yeah, that's something that GraphQL needs to come to Fabric. Yep.
Question for Andre.
Yeah.
Sounds like you're using OpenAI services to transform a lot of text, get rid of like bad words, replace them with other words. Are you doing any input, like training, based on your own data from within your company?
Yeah, that was the use case where I talked about retrieval augmented generation. It's not training per se, because those models, they're frozen. So like when you go to ChatGPT and you ask it about what's happening right now, it doesn't know, right? So you don't train it per se, because to train it you need serious hardware and time. But what you could do is you could use a RAG, retrieval augmented generation architecture, to effectively bring so the way this works is you have a PDF document with your knowledge. You convert PDF documents in what's called embeddings. And once you have that in embeddings, you can actually write a question, and that question is giving you an answer based on the meaning. Then you take that meaning, you build what's called the context, and you pass it along into the prompt, and then LLM models will look at your SOP or your knowledge base, manual, whatever the PDF document might be, and will use that information to respond to you as if it knows what's going on. So it looks like it's trained on your data, right? So for all intents and purposes, functionally, it looks like it's trained on your data. In reality, there's some creative engineering happening to make it look that way.
Are you auditing and logging
So what's interesting is, again, I think our world is completely going to change because we're going into the world where instead of writing, business rules and logic and if statements and rules engine and we're just replacing with prompts. So now prompts, you really need to understand. So different prompts work differently depending on the model you pick. If you go to OpenAI, there's a whole thing on how to do this. There's all these different models. They have their trade-offs. There's cost considerations, capabilities considerations. So a prompt that works for model A will not work for model B. So it does take, it's a really interesting how our skills have to evolve, where you go from speaking SQL, basically, to talk to your data, you now speak English, but you basically kind of get the same data back. But that doesn't mean that you could just, you have to understand how to talk to those technologies to get the reliable response. Because, those models hallucinate, there's a bunch of things that's happening. So you really need to, it's going to be completely new areas that we need to learn, but the capabilities are going to be well worth it. Yep.
Just a question on capacity. So obviously with the resource being managed within a capacity, if you hit, you mentioned capacity jail, if you run into capacity limits, obviously that's got a direct impact on your actual operation process of your run. How do you currently manage that if you do hit the capacity limit? Because I don't think there's anything.
Capacity limits, right?
Correct, yeah.
So the way capacities work, that's really worth everybody's while to go and study this up, right? So literally everything that runs in Fabric always runs with the same speed, right? So when you pick a capacity, you're not really picking how fast something runs, which is not intuitive, right? Like in our world, normally as you scale up, response time shrinks, or there's something that physical changes. In Fabric, it doesn't change. What happens basically is it just gets you into debt, right? So capacity just tells you how much debt you can take on before, actuarial model says that you're end of life, right? So you get throttled. So yes, absolutely. So figuring out capacity constraints. There are some features that are also based on capacity, because there is a bit of a scalability things, number of concurrent connections, number of jobs running, so there is some limitations in capacity. So yes, absolutely, you have to, once you're in Fabric, literally the capacity understanding what the cost is, figuring out what is the right capacity. In ideal world, you want capacity to match your demand. Because like the world we're living in, I may need this capacity today and this capacity tomorrow, and throughout the day my capacity demands might change. Right, so that's like one feedback from Microsoft. That's like an opportunity to.
Based on your current architecture use case, what capacity are you guys using to execute those?
I think we're like, what is it, fourth smallest from the bottom. So it's F16.
Yeah.
Yeah.
Yeah, and our use case is somewhat.
Is it F16, something like that?
Yeah. Yeah, ours is a bit more complicated than that because we are a SaaS platform. So what we've decided to do is customers tenants in our platform will all have their own capacity. For now, that's what we're going to do. That means that customers can manage their capacities themselves. What I would say about capacities in general, where I want to get to is, one massive capacity that we can put all of our customers in would be great, because it would reduce our costs and our customers' costs considerably. We're actuaries, we can figure it out, right? It's like, how much capacity do we need to service all of our customers? The experiment we're going to run is, let's have lots of capacities to start off with and see how utilized they are. So I think we're taking a data-driven approach to looking at what the capacities can be. And what we're going to do, and the advice we got, was start bigger than you think you need, because there's two things capacities are. One is they do give you flexibility to burst and smooth workloads out. And they're a lot cheaper than what you're currently paying, right? If you like, our bill right now in Azure on data is huge. I think our bill on Fabric, even if we pick big capacities, is going to be way less than it is today. So I'm not going to be too ambitious in how much less until I've got data, which the metrics app gives you. So what I would encourage you to do is spend more than you think you need, look at how much you use, take that data, and then adjust down from there.
And also, I love adding his point here. I know both the use cases, they use pipelines with notebooks, right? Staff team, they need a couple of features where you can queue, these notebooks while maintaining concurrency. So those features are coming
Yeah, I can go pretty deep on that if you want. So the reason we have 6,000 storage accounts right now is because of scale throughput. Because our compute platform writes, when it finishes running a model, when the node is done, when the CPU is finished, we write it to storage. Because storage is a lot cheaper than CPUs and RAM. So the quicker we can get the computers off, the better. Our utilization rate of our compute platform is around 80%, which is pretty good for such a bursty workload. But we do know that we've broke storage in the past, right? And that's a fact, and that's why we have so many storage accounts. But the way Fabric's architected is the workspace, which is the thing where you put your data, like lake houses live in a workspace. A workspace is a one-to-one mapping with an ADLS Gen 2 account. So an ADLS Gen 2 does have some elasticity in it. So if you are, like with us, our IOPS are off the charts. It can grow. There's limits to how much it can grow. IOPS are the bigger limiting factor. Bandwidth isn't as limiting factor as IOPS is. But you have a lever to pull because you can have more workspaces. So for us, what we're doing, because again, we're a SaaS platform, we have multiple tenants, we're going to have one lake. We're going to have workspaces per customers and capacities per customers. And because capacities and workspaces are decoupled, it enables us in the future to then have more than one workspace, which we need for data segregation and scale, but one capacity underpinning them all, so we can move to a single capacity model in the long run. So it seems like we've got a good approach. We don't have to manage all the storage accounts, we still have to manage workspaces, but we need to do that anyway for data segregation, and capacities give us the flexibility to move what we do around it.
It's sort of a loaded question because I know that in the Fabric capacity, so outside of Fabric, you have these IOPS costs.
Yep.
Reading rights, using separate.
Well, I think IOPS are in the capacity unit, aren't they? Are they out?
But I think
It's in storage.
because it uses capacity, you've got gigabytes of data that you write, you might use a big chunk of capacity just for ADLS.
Yeah. I asked that question, they weren't worried about that piece of it. I think one of the challenges you have with capacities is there's such disparate workloads running on them, and the most consuming end, the new AI skills, they're going to use tons of GPU and CPU and cost you lots of capacity, and then on the other end you got something like storage, which is marginal. So the way I think of it is like the stones in a jar. The sand is storage IOPS. It's not really going to impact stuff, I don't think. Do you have any thoughts?
I have a thought about capacity. I think we're not going to do what you guys are doing, move into one Uber capacity. I think we're going to have a bunch of different capacities, and if Microsoft does not make it easy stop and start, we're going to have to figure out how to manage it ourselves.
Yeah.
And so we're going to basically do the best we can to match compute with our demand. Because I can't just buy an Uber capacity and pray that our demand will just average out into this. So we're going to get really good and smart around making that match.
Yeah, and one of the concerns I have around the multiple smaller ones is if Microsoft start to license specific features for bigger capacities.
Yes, which they are.
Which they're going to do. So I think we have to watch and see, and that's part of the hedge there. What I don't want to do, and this is an interesting question, if auto scale comes in, which is be great, right? Yeah. And you have your Uber capacity and it's growing and shrinking for you, there is going to be a minimal cost to your capacity if the features you need are in the bigger one. What happens if you scale into the bigger one and down again? Do you get the feature for a little bit?
If it's not used on weekends, do you just want to keep it running?
Yeah, and pausing is a thing that they support today. So that's another good lever you can pull.
Auto scaling is coming, but auto pausing, there's nothing official.
I would encourage to meet with Microsoft people. Go to one lake sessions, go to some of